Hey everyone, let's talk about a word you probably use, I don't know, 100 times a day without even thinking about it. The word not. Super simple, right? Well, what if I told you that in the world of advanced logic, this tiny, everyday word actually splits into two completely different ideas? Yeah, it's kind of wild. You ready to see how deep this rabbit hole goes? Let's get into it.
So here's our game plan. First up, we're going to look at the problem with not itself. Then we'll find the key, and it's all about defining this one word, absurdity. You'll see how that one definition is what creates the two different types of contradiction. After that, we'll explore why this matters so much, looking at something called intuitionistic logic. And finally, we'll wrap it all up with the big takeaway, the difference between not true and proven false. Sound good? Let's go.
Okay, section 1. Let's jump right in. What is the big deal with not? I mean, it seems like the simplest word in the world, but it's hiding a secret. It's about to split right down the middle.
I mean, think about it. Every single day, you say things like, I'm not going, or that's not right. It feels totally straightforward, you know? Like you're just flipping a switch from on to off. But is the logic engine running underneath it all really that simple? Is it always doing the exact same job? And, well, you probably guessed it. The answer is a big nope. Once you move past everyday chatter and into the super precise world of formal logic, that simple idea of not starts to, well, it fractures, it breaks apart, and it turns out there were two completely different concepts hiding inside that one little word the entire time. So, how do we make sense of this split? Well, the secret, the absolute key to unlocking this whole thing, comes down to how we define just one idea: absurdity. You see, in a lot of logical systems, negation isn't just a word. It has a very precise definition. Saying not A is basically just shorthand. It really means statement A leads to absurdity. Now that might sound a little academic, but think of it this way. Imagine you assume something is true, and by following the rules of logic, that assumption leads you to a total dead end, something completely impossible. Well, what does that tell you? It tells you your starting assumption had to be wrong.
And right there, that's the whole ballgame. Everything, and I mean everything, comes down to this one question. What exactly is that logical dead end? What do we mean by absurd? Because as you're about to see, the way you answer that question is precisely what causes our little word not to split in two.
So answering that question leads us to two different kinds of contradiction. And this is where we finally get to meet the two different flavors of not we've been talking about: positive and negative negation.
All right, so check this out. It all boils down to these two paths. On one side, you've got negative negation. Here, absurdity just means a classic contradiction, like saying A and not A at the same time. It's a statement that basically eats itself. It just self-destructs. But then, on the other side, you have positive negation. And this is different. Here, absurdity isn't about self-contradiction. It's about hitting a fundamental falsehood, something that is just plain wrong based on the ground rules of the system. The classic example is saying 0 equals 1. It's not that it contradicts itself, it's that it breaks a core rule. So you've got self-destruction versus breaking a fundamental law.
And hey, this isn't some newfangled idea. The legendary logician Alonzo Church actually ran right into this problem. He introduced a symbol for falsehood into his work, but he never actually said which kind it was. Was it the self-destructing kind or the rule-breaking kind? He left it ambiguous, which just goes to show you that logicians have been wrestling with this puzzle for a long, long time.
Okay, so this is all really interesting theory, but you might be thinking, so what? Does this actually matter in the real world? And the answer is a huge yes. It has massive consequences. And to see just how big, we're going to dive into a really fascinating case study, a field called intuitionistic logic.
So, what on earth is intuitionistic logic? Well, the easiest way to think about it is as the show me the proof school of logic. For them, a statement isn't true unless you can actually build a direct, step-by-step constructive proof for it. You can't just say, well, it's got to be either true or false. They reject that. And here's the kicker. For an intuitionist, just because something is factually wrong, that doesn't automatically mean it's a logical absurdity. Those are two different things. And because their rules for proof are so strict, they really only have one major tool in their toolbox for proving that something is false. It's a classic, famous method you might have heard of: reductio ad absurdum, the old reduction to absurdity. So how does this thing actually work? It's pretty straightforward, really, just 3 steps. First, you take the statement you want to prove is false, and you pretend it's true, just for argument's sake. Second, you follow where that assumption leads you, logically. If that path takes you to something completely absurd, like you end up proving that 0 equals 1, then you get to step 3. You can then say with confidence, okay, my original assumption must have been false. This is how they actually build a proof of falsehood. It's an active process.
And all of that brings us right here to our final section. This is really the big payoff for everything we've talked about. It's all about finally understanding the huge difference between something being not true and something being proven false.
So, after splitting not in two, defining absurdity, and taking a trip through intuitionism, it all boils down to this one single crucial point. In a system like intuitionistic logic, just because you haven't managed to build a proof that something is true, that is absolutely not the same thing as having a proof that it's false. See the difference? Not having a proof of truth, that's our negative negation. But having a proof of falsehood, by showing it leads to absurdity, that's our positive negation. They are two totally separate ideas. And that, right there, is the entire universe of complexity hiding inside that one little word, not. Kind of makes you think, doesn't it? What other simple, everyday words are we all using that are hiding this much depth? What else is out there, just waiting for us to look a little closer? Thanks so much for digging into this with me.